So welcome, welcome everyone to a new edition of a BTune webinar, the Beekeeping Educational Platform. Today we will talk about honeybee nutrition, when, how, and what to feed for optimal hive health and productivity. As winter is coming, it's time to start thinking about the well-being of our bee colonies. My name, I think you mostly know me, it's Miguel Angel Rodriguez. I'm Beto Pharma Bee Business Director. But today we have the pleasure of having a magnificent speaker of recognized international prestige, Dr. Gordon Wardell. So thank you, Gordy, for sharing your time with us.
My pleasure.
Before moving on to the presentation, I would like to explain shortly the dynamics of the webinar and share a brief view of our speaker. So the presentation lasts approximately 40-45 minutes. Right after, we will have a short Q&A session of about 15 minutes with the questions that you will be typing in the chat during the webinar. So don't forget to ask any questions to our speaker. My team will be taking care of all your inputs. Any question that cannot be answered during the event, we will try to answer them later anyway. As I have just mentioned before, we are joined today by Dr. Gordon Wardell. So Gordy, as he prefers us to call him, has worn a number of hats in the industry, serving as chairman of the US-based nonprofit project Apis mellifera, director of pollination for California's Wonderful Orchards, and extension apiculturist for the University of Maryland. After initially receiving his PhD from Michigan State University in the 1970s, Gordy went on the lead beekeeping development projects in Southeast Asia during the 80s, found it safe in the 2000 to explore critical areas of bee research in collaboration with the USDA team in Tucson, Arizona. And more recently, he has taught beekeeping courses at California Polytechnic University in San Luis Obispo. So Gordy, Dr. Wardell, thank you for joining us today. And that's all on my side. So the stage is yours. I will just share my screen and start with the presentation.
Okay, thank you, Miguel. That's a very generous introduction.
Everything you deserve it. Well deserved.
Okay, thank you. So today, what I'd like to talk about is honeybee. We're going to talk about honeybee nutrition, but I want to sort of angle it toward what we need to do in the fall to get our bees ready for the fall. This is probably the most difficult time of year for bee management, to really manage your bees properly. In the springtime, it's easy to be a beekeeper. Their flowers are blooming and the hive is going into that exponential growth phase. The bees are humming. Springtime is easy. In the summertime, when the bees are in production mode, putting away lots of honey, that's still an easy time. But in the fall is the time of year, I call it the transition, when we're transitioning from summer bees to winter bees. And the bees have to go through that long winter, sometimes 4 and 5 months of winter where they have very little out there for them. So what I'm going to focus on today is how to manage your colonies, how to feed your colonies, how to get everything ready for the winter, have them go through the winter very well. And then next spring, we'll do another seminar on how to manage in the springtime. So let's start with the first slide. To back up a bit, when I was first asked to look into bee nutrition, I was at the Tucson Bee Lab in Tucson, Arizona. Had my research and development company there. And several beekeepers came to me and they said, Gordy, we want a better bee nutrition product, something that really helps our bees out better than what we've currently got. So I went to the literature. I started looking at what's in the literature and what's been done already. And I came across a paper that really got me intrigued. It was by a fellow named Keith Dole. And Keith did a paper where he looked at feeding nutritional supplement to bees year-round. He gave the bees, one set of bees, a group of bees, he gave them protein supplement year-round. He monitored how many bees were in the hive, how much honey they had, what kind of brood they had, all the different parameters you'd want to know in the hive, how the protein supplement was managed in the bees. And then he had another set of colonies that were controls that received no supplementation at all. And after a year, he looked at his data and he found that the bees that ate the protein supplement produced more young bees than the control group, but it wasn't statistically significantly more. So he had more bees. And the other thing that Keith was doing in this study is he did it originally for the honey producers to see if feeding protein to the bees improved honey production. And what he found was the colonies that were fed the protein supplement did produce more honey, but they didn't do it with significantly more bees. So there was more honey, just about the same number of bees. And the question was, how did the bees do it? How do you make more honey? They don't have bigger buckets to bring it home in. What happened was the bees that were fed the supplement were living longer. And that's a lesson that's really good for us. And we'll try to take that living longer lesson today into our presentation and talk about fall management and what happens if we can get our bees to live a little bit longer in the fall and in the winter. So our first slide here, what everybody should do when you're getting ready for fall is start your inspections. And good wintering, as we all know, begins in the fall. We start this in August. Good wintering really starts in August because that's when we start doing our fall inspections, when we're examining what's in the hive. And you always want to know what's going on, what's the egg, what's egg production like in the hive? What's got a lot of larvae. What about the pupae in the hive? How are they looking? House bees. Do we have a good population of bees that are nurses and managing the house of the colony? And then, of course, field bees. Do you have a good field bee population? Lots of activity at the front door. And then, of course, as you're going through your inspections, you're looking for diseases, both brood diseases and adult diseases. You look for deformed wing virus. You look for larval diseases. You're looking at all these different things, both the larva, the pupa, the adult bees. You're checking all these things out. And then you also look at the health of the queen. What is their egg pattern like? And once you get through all of that, then you've got a good picture of your hive. Then you can make your assessment as to what the hive really needs. So let's go to the next slide. There we go. Fall inspections, what you're going to see in your fall inspection is going to look a little different than your summer inspection. Notice the photo on the left is a fall one, and the one on the right is summer frame. Notice the difference between the two brood. Both have brood, but notice how the fall has honey stores in around the brood nest, lots of pollen stored away, and the summer is just flat out production. They're eating it as fast as it comes in and turning it over into bees to produce that surplus. Okay, let's go to the next slide. The thing we want to do in the fall is, the first thing we have to do in the fall is take care of mite problems. A lot of people, I've had people tell me, oh, I don't believe in treating for mites. And all I can say is that having a honeybee colony and treating for mites is kind of like going skydiving. You don't have to have a parachute to go skydiving unless you want to do it a second time. And not treating your colony for mites is a big no-no. You have to treat your colony for mites and get mites under control. And once you do that, then you'll be able to do some protein supplementation, or the bees will make young bees that are mite free and will live longer. The average bee that's preyed upon by a mite shortens its life by, oh gosh, about half. And bee mites that I'm sorry, about a quarter. And bees that are preyed on by 2 mites shortens its life by a half. Now you take a 180-day bee and shorten its life down to 90 days, and you've got bees dying in December, and you won't have enough bees to go through the winter. So you really need your bees to live as long as they can in the wintertime. And mite control is your first thing that you can do to help bees live through the winter. So once you get your mite control done, then we want to talk about nutrition and about supplementation possibly. And feeding your colony is nothing more than population management, and that's really all beekeeping is population management. But feeding your colony it's a tool. Protein supplement you put in the hive or sugar syrup you put in the hive is a tool that we have in our beekeepers' bag of tricks that we can help manage the population in the hive. And what we're doing when we feed protein supplements or pollen, if you have it, if you've captured your own pollen, you want to feed it back, that's good too. But you're stimulating brood production, and you're stimulating the production of longer-lived bees. And so you're just basically managing the population of bees in your hive. And these young bees that are being produced are going to be a little bit fatter. They're going to be a little bit bigger. They're going to be what we call winter bees. And that's all a matter of producing vitellogenin. And vitellogenin is a protein, lipid, carbohydrate complex. It's a storage product in the bees. There's many different ways. There's 2 different ways that bees store protein in the hive. One is they bring pollen in and they put it in cells and they store it in the cell and make bee bread out of it. The other way bees store protein is in their bodies, and the bees themselves become the storage organs. And for the winter, we're creating fat bees. So Miguel, the next slide. So this is typically what you see in the fall when the bees are shutting that queen down. So you can see in the middle, the cells in the middle are being filled with honey as it's coming into the hive, and there's a competition going on in the hive between the queen and the workers. The workers are trying to shut her down because they don't want to make too many babies to go into winter with. But at the same time, she's trying to lay as many eggs to get as many young bees out there as possible. So as cells are becoming available, the bees are going through and putting nectar in that to push her down. And this process of filling the cells at the top of the frame and working down is how the bees work the queen down to the bottom of the hive for the wintertime. And that's really cool because they want to get the queen down at the bottom of the hive. So as winter goes, they'll move up through the hive, consuming the honey. If they start at the top, it's hard for them to go down in the hive to consume honey. As they're moving up, they're warming up the honey that's above them and getting that honey ready to be used and all. So they want to start off and get the queen down at the bottom and start her off at the bottom. So we can go to the next slide, Miguel. So this pushing the queen down and slowing the queen down is in the fall. As the days are getting shorter, the queen's not laying as many eggs. And what happens is we're starting to transition into winter bees. And by slowing down the queen's egg laying, the nurse bee to brood ratio begins to shift. You get a shift in this hive. The hive is in transition. We're shifting from summer to winter. And that shift, when you've all of a sudden now you've got more nurse bees in the hive, then you've got brood, and you're shifting from a lot of brood and a few nurses to a lot of nurses and a few brood. What happens then is there's still bees. It takes 21 days to go from egg to adult. So what you get is bees emerging. They're doing what nurse bees always do, is eat pollen or protein supplement, eat the diet, start producing royal jelly in those hypopharyngeal glands, those glands that are in their face that makes royal jelly. And then they start feeding the larvae. Well, the larvae that are there get fed really well. And pretty soon the nurse bees are feeding the larvae, but the larvae can only take so much. And the nurses are saying, well, what am I going to do with this? So the nurses pass it around in the hive. The royal jelly gets passed to the adult bees as well. And the adult bees are internalizing this royal jelly, and it's turning into vitalogenin, that lipid protein carbohydrate complex, and it's stored in fat on the inside of their abdomen. And that's the winter stores that they're going into winter with. So they become winter bees or fat bees. The amount of foraging, because you're going into winter and there's not a lot of flowers out there, the amount of foraging shuts down. And so because the bees aren't flying as much, they're not burning off that fat that they're producing. So they're storing more and more fat. And other things in the hive change as well. We have the queen, for instance, shifts in pheromone production. It's not necessary for her to manage, to put out pheromone to control a large colony of bees anymore. It takes a lot of energy to produce that pheromone. So the queen isn't producing as much pheromone as she normally produces. And many of you may see about the queen pheromone, you may see supersedure cells in the fall. This is a function of the queen slowing down her pheromone production. And the bees in the hive are saying, well, I'm not smelling the queen. And they may even make supersedure cells in the late fall because they're worried that there is a problem with the queen. There was a fellow in Michigan that worked out a whole line of bees that would produce these supersedure cells, and the old queen and new queen would live together side by side in the winter until spring, and then one of them would disappear. But the hive was naturally requeening itself every fall. It was a kind of a neat phenomena, but that's very typical as queen's pheromone is shutting down. She's more stealth in the hive. She's not that big pheromone presence that she always has been. And the other thing that happens in the fall is brood pheromone drops off too. Brood pheromone, because you're not producing as much brood, the brood pheromones start slowing down. And that slowdown in brood pheromone in the hive, what that does is it doesn't call for as much pollen to be foraged because there's not as much demand. And you're not sending bees out to forage something they may not need. And that pollen and those empty flights in the late fall when there's no flowers out there, those empty flights would only mean bees burning more energy. So this is one way. Brood pheromone slowing down, demand for pollen slows down, demand for foraging slows down, and the bees they maintain that protein in their bodies and they stay healthy longer. So really all these physiological changes are happening in the hive, and that's what's really cool about it. And the other physiological change that happens is that as the bees are getting ready for winter, they're eating these carbohydrates and they're turning sugars into glycols and other higher sugars in their blood. And those higher sugars help them withstand freezing temperatures. They can literally go down below freezing without having cells rupture in their body and damaging them. So we can have another talk about winter physiology, but I think that's a really cool thing where bees literally store sugars in their body that are that help them go through cold temperatures and also act as a storage product that they can call on later and turn that into energy. Next slide, please. So what beekeepers need to do in the fall is to make sure there's adequate resources in the hive for the winter. You need to look through your hive, make sure it's heavy enough, you've got enough honey stored. And if there isn't, you need to feed. And feeding sugar syrup is the best way to do it. But this time of year and in the winter, you want to feed heavy syrup. In other words, sugar syrup that's 2 parts sugar, 1 part water. That's a heavy syrup. If you feed anything lighter than that, 1-to-1 syrup, like for instance, the bees would have to evaporate moisture out of it to get it ready for storage, winter storage, and that would chill down the hive, and you don't want to do that. So feeding heavy syrup is the best way this time of year to put extra weight on your hives if they don't have enough honey stored for the winter. Okay. Next slide, Miguel. Thank you. And there's many different ways to feed sugar syrup to your bees. There's probably as many different ways to feed sugar syrup as there are beekeepers, because beekeepers are always creative and come up with new ideas on ways to feed it. But you can see a couple here with black bottles that I like because they it warms the syrup in the fall and winter, and the bees like it. Or the cans inside an empty shell on a hive. Many different ways to feed syrup. Okay. And then feeding protein supplement. And this is pretty much what I wanted to give the talk about today, is how to get extra protein in your bees. But the photograph that's on the left is one of my favorites, because that shows you how a bee eats anything. Everything the bee eats is turned into a slurry and goes up their honey tongue. We think about protein supplements in the hive, these pollen patties or pollen in the cells, and we think about bees going in with their mandibles and taking a big bite, chewing it and swallowing it. That's not how it happens. What happens is all of these things we put in the hive, like protein patties or sugar patties and things like that, fondant, it all disappears one lick at a time. So everything that goes into the bee has to be turned into a slurry and then is sucked up through the proboscis. And we'll talk about particle size later and why that's important. But the reason we feed protein in the hive is we want to increase the population in the hive. We're, of course, building winter bees, and we're giving bees more protein that help them build their immune system and be stronger. And it also helps bees, build more brood in the hive if they need more brood. So that's why we're feeding protein, and we'll talk a little bit about what protein to feed in a little bit. Next. So the nutritional, the link between colony health and nutrition, you have to look at the colony. There's something a lot of people don't think about, is the honeybee colony is a series of overlapping generations in the hive. There's the queen's laying eggs constantly and turning over new generations. And what Keith Dole's, that paper I talked about right at the very beginning, and what this slide have in common is this talks about bees living longer. And if the longer an individual bee lives, the greater the overlap between the populations. So just imagine a bee that's living 60 days and a bee that's living 45 days. You're not getting as much overlap in the populations, and the population in the colony is going to be smaller. So the greater the overlap in the populations in the hive, the greater the strength of the hive, and that allows bees to remain in their specific duties longer. In other words, nurse bees stay in the hive and nurse longer, because we know that when protein levels start to drop in a nurse bee, juvenile hormone levels come up, and what happens is she is then goes to field duty. She goes to the guard duty, eventually to field duty in the hive. But the longer she maintains high protein in her body, she stays in that nursing job longer. The longer, if you have got more nurses in the hive, you're producing more royal jelly and you're producing a healthier hive. All of these things we put in the hive, like pollen, protein, carbohydrates, sugar, all of these things are the groceries in the hive. These are the nutrition that the hive brings back, but they're not always ready for the hive. They have to be turned into readily available food, and the readily available food in the hive is royal jelly. So the longer you can keep nurse bees in the hive producing royal jelly, the healthier hive is going to be, because it's royal jelly that runs the hive. Just like you, when you go to the supermarket or you go to the market and you bring back food, you don't grab a piece of chicken and start eating it right away. You cook it. Nurse bees are the cooks in the hive. They cook the protein and turn it into readily available food, which is royal jelly, which runs the hive. So the elements of a good diet are carbohydrates, protein, lipids, and all of these things are linked to longevity in the hive. And the longer an individual bee lives, the healthier hive. And so that's all we're trying to do with supplemental feeding, is to get our bees to live longer. Okay, there we go. So I talked about royal jelly production. These are the actual glands that produce the royal jelly out of the face of the bee. These are tiny little glands that are right behind the eyes of the bee, and these ocini are the little grape-like things, and they are part of the hypopharyngeal glands that produce the royal jelly. The whiter and fluffier the little grape-like things are, the more royal jelly is being produced. And this is from a study that I did early on, comparing different products, both a control product, which was just sugar syrup, a protein supplement that I developed, Mega Bee, a competitor's product, and then natural pollen. And we put these on bees in a cage, fed them over time, and monitored the hypopharyngeal gland development over time. So after the first week, you can see everybody's producing royal jelly and producing a lot of it. Go to the next slide. So this is, we call it the transition. This is when things start to change. You can see the control that just gets the sugar syrup. They're not, the cells are getting kind of light and almost translucent, transparent. They're not producing as much royal jelly. Then the other products, the Mega Bee and the pollen and the competitor's product, are starting to change as well, but pollen and Mega Bee are doing very well. Next slide. And this is when things start to drop off in week 3, with the control and the competitor's product, and even natural pollen is starting to produce less than the Mega Bee is producing. And so over time, we're able, if these bees are producing more royal jelly, that'll keep those nurses in the hive longer, taking care of the brood and managing things in the hive. Next slide. And at the end, we can see that after the 4th week, there's very little being produced in anything except the Mega Bee hive. This is all important because it shows us that we can keep the bees in the hive longer. How does that happen? Let's go to the next slide. So how does that happen? How is one product better for the bees than another? Well, a balanced a balanced protein supplement, a balanced protein profile in the diet is of course important. All 10 essential amino acids that are needed by the workers to develop royal jelly and keep them going longer. But also, one thing we found was the particle size was important. Imagine a 50 micron particle, and you divide that particle in half. You haven't doubled the surface area of that particle. You've quadrupled the surface area of that particle. And what the greater surface area does means that bees can absorb it into their system faster. There's more surface area, so they can digest it faster. So it's easier for them to digest, and they get the protein into their bodies faster. Because think about it, you've only got a short time for something to go through the bee's gut to have it absorbed. So something smaller, absorbed faster, that's what you want to see, is you're getting protein into their bodies faster. Okay, next slide. So back to fall management. So let's talk about how all of that, what we just learned, is going to apply to our fall management and keeping our colonies strong. So you check for honey stores, taking care of colonies that are, if they're too weak, you want to unite colonies. You can feed all the protein supplement you want, but if you don't have enough bees in the hive to go through the winter, you need to take weak colonies and unite them together. And I always tell beekeepers, you take your losses early. You take the colonies that you don't think is going to make it through the winter, put it on another, put two of them together, or put the weak colony on a stronger colony, and unite them. Winter, this is the time of year also to take a look at your equipment and replace damaged equipment. Put on your mouse guards, because nothing will kill a hive faster than a mouse getting into your hive in the wintertime. And it's not because they're eating the stores, they're eating the honey or anything that's going on. It's they disturb the hive. They're disturbing the bees, and the bees break cluster when they're disturbed by a mouse. They break cluster and try to chase the mouse out. And when they break cluster, they lose heat. And it takes a lot of energy then to get the heat back into that cluster. The cluster in a hive is mainly about 33 degrees Celsius when they're raising brood, but only 20 degrees Celsius when they're not raising brood. So you see the difference in brood nest temperature, but it's important to keep that temperature stable. So disturbances like mice in a hive, they'll surely kill a hive. And the other thing you want to think about for the winter is moisture control, because that'll chill the hive. Too much moisture in the hive, and it'll chill the hive and spawn dysentery in the hive as well. So let's go to the next slide. This is just a slide of uniting colonies. We're putting here on the right-hand side, we're putting combining two weak colonies together, and just put a piece of newspaper between them. And that gives the bees enough time to adjust to each other's scent, that they don't fight right away. And then on the left, it's just a way to unite a nucleus colony into a bigger colony. There's a board there just with a hole in it that allows the bees in the nuke hive to eventually unite to the colony down below it. So this is just one way to keep them stronger. So wintertime, why do we lose so many bees in the winter? Well, I think here in the United States, our biggest problem is mites. Our biggest problem is mites and the viruses that the mites are vectoring to our bees. I think that's why our national average is somewhere between 30 and 40% of the colonies die every winter due to maladies, and I attribute most of it to mites. But some colonies also just run out of food. They run out of stores and die of starvation. And if there's not enough bees in the hive, if the bees are dying too young, like I mentioned, if a mites are preying on the bees, and the bees are dying young and not able to live through the winter, then your colony population is diminishing, and they're not able to maintain brood nest temperature, and they literally freeze to death because they're not able to maintain proper brood nest. And being locked into the hive too long, you notice the photograph of the hive on the right there shows a photograph of a colony that the entrance is sealed off by snow, and there's no way for those bees to get out. That's even in the winter, the bees will get out and void their waste, even when it's freezing out. As long as it's a sunny day, they'll get out and fly, and most of them will make it back. But not able to get out and void themselves is a problem. And like I said, parasitic mite syndrome and all the viruses that have vectors are a big problem. And then excessive moisture and poor ventilation will kill colonies too. So these are all things to look at and manage for yourself, and good air drainage around your colonies too. Having good air moving away from the colonies has been shown. Folks out at Penn State did some really interesting work on location of colonies, putting colonies on hilltops and sides of hills and sheltered areas. And they found that areas with good air drainage away from the hives did better. And so this is probably a moisture issue, if you ask me. But it was an interesting study. And next. These are just different ways to manage moisture in the hive. The hive on the right has fiberboard in there that absorbs moisture out of the colony over the winter. And the one on the left is just showing without the fiberboard. But you can also use wood chips. You can use any number of absorbent products to put above the hive, straw, hay, things like that. Put it in a cloth sack and put it above, and it'll absorb the moisture from the hive. And then good ventilation, just having a little upper entrance so the bees can get fresh air is always important too. So keys to good wintering success are good colony populations, plenty of food reserves, good location, manage the outside pests, things as mice and moths. Having healthy bees going in the winter is the best way to make sure you make it through the winter. And then, of course, there's luck. We all need a lot of luck when it comes to getting our bees through the winter. I think that's about all I've got. If there's any questions, I think we've got plenty of time.
Yes. Yeah, thank you very much, Gordy. I think thanks for sharing all your knowledge and for stick on the time perfectly well, these 40 minutes. So we can open right now the Q&A session. So we probably have some good questions here on the chat. So let me just check it. So first question, if you collected a hive that was on its own for 3 years and it's super strong and healthy, do you treat them for mites when they obviously did very well with no humans around?
Well, I don't know the I've had people tell me they've had a bee tree in the side of the yard, and it's had bees for years. And if you look at it closely, the bees have come and gone several times in that hive. They've died off and new bees have come in, because most of the time people aren't really watching wild hives. But if this truly was a hive that was on its own, it's a good stock to have. I'd say yes, get that stock. But I check everything for mites. Get one of those little mite shakers that Vita Pharma produces, man. That tells you right away. But yeah, I would definitely check for mites, but that would be the kind of stock that I would want to have if it's been 3 years. And there was a researcher at Cornell that recently did work and found that bees were coming back to natural areas, bee trees and things like that. And what he found was the mites are different in rural locations. In other words, if the hive is separated from other bees, the mites are different. They're not as aggressive about killing the hive. They've formed not a symbiosis, but at least a tolerance. The bees have developed tolerance with those mites. And the thing that we have with our bees is, and especially here in the United States, we'll have sometimes as many as 50 or 100 beehives in one location. If the mites kill a colony, we reward those bees. We reward those mites by giving them another hive to move to right next door. They get rewarded because as soon as that hive dies out, bees go in, rob it out, take all those mites to the next hive, and it goes on and on. So finding a hive that is resistant or tolerant to the mites, that's the way we need to go with mite control, is finding mites that are finding bees that are tolerant to the mites and can manage the mites. So I would say take that hive and let me know how it works out.
So next question, maybe a naive question, but can you physically identify fat winter bees?
Well, you can, but you have to cut them open.
For sure.
You have to open them up and examine the hemolymph, or examine the fat that's stored on the inside of the abdomen. But no, they don't look that much different from summer bees. It's just they have more stores inside. But you need to, a beekeeper needs to do his job, making sure that fat bees are being produced, and by making sure they have enough protein, they have enough carbohydrates to produce brood. And your job as a beekeeper is to watch the colony and manage that population. Usually what I do in the fall to make sure I've got fat bees is I get my mite treatments done in August, get my honey off, get my mite treatments done, and then I feed a round of protein patty, and they'll take it down right away. And then I put another protein treatment on there after about 2 weeks. And after that, I cut it off because I know I've stimulated them enough to produce enough brood that they can then go into winter with. Is that helpful?
Yeah, absolutely. So there's another question here. Do you recommend feeding protein as a patty or powder? I've read studies that show the workers don't actually consume the patty, but carry it outside of the hive.
Well, that's easy enough to check by putting a little tray outside the hive and see if you can collect it. But if the patty is soft and edible, they'll eat it. I mean, I've got the data showing that they eat it and it goes into their blood, and the hemolymph proteins increase. And if you want to do another talk about that sometime, I could show you all the data on how feeding patty to the hive actually gets into the bees. But feeding powder, a lot of beekeepers dry feed their bees. They'll put the powder out and the bees will dip into it and pack it on their back legs, bring it back to the hive. And that's a great way to get the powder into the hive. And the bees in that case are doing exactly what they're designed to do, and that's they're hoarding that pollen, that protein supplement. They're bringing it back and they're hoarding it. They're putting it in the hive and they're storing it away for a later time. By putting the patty in the hive, you're stimulating their hygienic behavior, saying, oh, who put this glop of stuff right over my head? I got to get this out of here. And the only way the bees have to get it out is to, like I showed you on that slide, is lick it and consume it to get rid of it. Bees, I had a lot of technicians over the years watch bees work on different patties, and you never see them go up with their mandibles and take pieces of it to remove it and take it out of the hive. They're always up there licking it to get rid of it. If a patty gets hard and unedible, yes, the bees will break it up into small pieces and take it out of the hive. But if it's soft and edible, they'll eat it, especially if it's a good protein mix. They'll eat it. Oh, but one more thing.
Yeah, sure.
About the dry feeding. I like dry feeding, but when I'm putting stuff in the hive, protein supplement in the hive, I want to stimulate my weakest colonies, and the strong colonies is important to stimulate them too, but I'm really trying to stimulate my weak colonies and get them to build up a little bit. And when you put a protein supplement out in the yard, the strongest hives will dominate that resource. So the strongest colonies will get the most, and the weakest colonies that have the fewest number of bees to send out to forage will get the least. So you're not really helping the weaker colonies, if that helps.
Okay, so we have another question related to, besides protein and carbohydrates for bee nutrition, where do probiotics fit into the scheme of honeybee nutrition? Also, do probiotics help in developing healthy winter bees?
Well, probiotics, what probiotics do is and I consider probiotics and prebiotics, and I'll define those in a second.
Mm-hmm.
But what they do is they help the bees digest the food. So you've got several hundred different bacteria, probably millions of different types of bacteria in their gut, that break down this protein that we're feeding them and turn that into available energy and amino acids in the hive. So what probiotics do is they help the bees break down that. And when I was talking about prebiotics, what I'm talking about is things that will help even stimulate the bacteria. And that was something we did early on with Megabee, is looked at what beneficial bacteria grow on the patty in the hive, and we found the same bacteria, the lactobacillus bacteria and a couple other important bacteria, growing on the surface of the patty as the bees were eating it, because they're going up and licking it, and they're transferring these bacteria, these probiotic bacteria, to the patty and pre-digesting it even as it's in the hive. So good question about the probiotics, and do they help? Yes, they're involved in helping assimilate that into the bee's body.
Okay. Another question, it's what time in the late summer, early fall should you be adding sufficient protein to the hive to create the winter bees?
Well, it depends on
the supplementation,
right. It depends on what your annual cycle is. So, in other words, like I said earlier, I usually get my honey off in August, and then I do my mite treatment, and then I usually finish my feeding by mid-October, and I'm done, and let the bees manage their nest after that and close down. So, but it depends on where you are, and you need to look at your cycle, where your flowers are. So when your flowers are coming to an end, that's the time to think about protein supplementation if you need it in your hive. You may not need it. You may have an area that has plenty of pollen. Your bees are busting out of the hive. They're doing great. You're in good shape as far as you're in good shape as far as population goes, and you've got a lot of brood in the hive. But again, protein supplementation is a tool. It's something that gives you the ability to manage the population in the hive.
Okay, we have another question from Veronica. Have you heard of bananas providing helpful nutrition?
Ah,
Have you ever tried?
Veronica. Good question. You know what I've heard of using bananas for, and this goes back quite a ways. I heard of using bananas for chalk brood disease in the hive. I've had old beekeepers tell me if you've got a bad chalk brood problem, put bananas in the hive, and that will cure up the chalk brood. And there's a lot of potassium in bananas, and it could be the potassium. I did some looking into it, did some reading on it, and chalk brood is susceptible to potassium. So that's the only thing I've heard about with bananas is controlling chalk brood disease in the hives. But as far as a balanced nutrition, no, I haven't heard of bananas as a balanced nutrition.
Well, I think you already mentioned, but if you want to complement, with this question, the relationship between microbiota, probiotics, and immunosystem, you started sharing some thoughts, but maybe you just want to make a link on these concepts.
Probiotics, and repeat it again.
Microbiota, probiotics, okay, and the immunosystem.
Okay, yeah. Again, a good question. The probiotics and the microbiota that's in the bee's gut. What's interesting about feeding a protein supplement is that you need to have enough fiber in the diet as well. Just like we need fiber in our diet, the bees need fiber in that, and pollen grains act as a fiber source for the bees. And it's a Anderson and in Tucson did a really neat study on it, showing how the probiotic bacteria cling to the pollen grain, and he wondered if they were absorbing the cellulose of the pollen grain. But what it was, they were using it as a platform. They were adhering to it as a perch, if you will, someplace to set up shop. So fiber is needed. Probiotics, they are important because, again, what they help do is help digest everything in the bee's gut and produce a lot of important other chemicals that are important to the bee, and help put oils and fats in the right conditions to be used as pheromones. We know we need we have so many different pheromones, 27 different recognizable pheromones just in a worker bee. So all those pheromones depend on the lipids being manipulated enough and put in the right condition. They can be absorbed through the gut into the hemolymph and then used for the bee. So that's what probiotics do.
Okay, we have another question that it says, as the queen ages in the spring when pheromone levels are going up, does an older queen rebound to a lower pheromone level? I don't know if you may have an answer for that.
Repeat that one more time for me.
As the queen ages in the spring when pheromone levels are going up, does an older queen rebound to a lower pheromone level?
Oh, does the older queen rebound?
Yes. To a lower pheromone level?
I don't know if she rebounds to a lower pheromone level than she had in the fall. I don't have that information, but I do know that in the winter, the queen starts laying eggs even in January, and pheromone levels start to come up. If, as the colony is growing, the queen isn't producing enough pheromone, that's when the bees will supersede her or swarm. And so does she rebound to a lower level? I don't have that data. I would only be guessing if I said anything. But she does rebound, and she does start producing pheromone. And her pheromone production, of course, will, if she's not producing enough pheromone, that hive will swarm even sooner than it would if she had a large pheromone presence. That's why a lot of beekeepers, a lot of commercial beekeepers, will requeen in the fall, going into the winter with a very strong queen, so they have a strong queen and have less swarming in the spring.
Well, they are sharing in the chat that you already answered the question, so you did it well anyway.
Okay.
Perfect. Anthony Antonucci, it's also complementing, I think, your previous answer. They say bananas stimulate hygienic behavior in bees, which could make them clean out the large with chalbrooked. So it makes sense also what you shared. Yep. Thanks, Anthony, for sharing that.
Yeah.
Well, I think that's we have already completed most of the questions. I hope everyone has enjoyed and learned something today. I would like to thank all the attendees for their participation in the chat, and of course our speaker today for his great educational capacity and for all the support in the development of this event from the beginning. In the next few days, we will send you a link with the recording of the webinar, so you will have all also available, the slides shortly. We are already working on the next webinars, which we hope will be as least as interested as the one we held today. And thank you very much, everyone. Thank you very much, Gordy, and hope to see you soon.
Thank you, Miguel, and thanks for all the great questions, folks. Bye now.
Thanks. Enjoy your evening. Bye-bye. Enjoy your day.